the morning of October the 9th, 2022, a wave of radiation washed silently over the Earth. It did not announce itself. Nobody felt it. No alarm went off in any city, and the sky did not change color. And yet, in that moment, for a fraction of a second, our entire planet was bathed in the most violent light the universe has produced since the Big Bang. It had been traveling toward us for nearly 2 billion years. It left its source before anything on Earth had a backbone, before there were fish or forests or eyes to see it coming. It crossed a distance the human mind cannot hold, and then it arrived on an ordinary autumn day and passed straight through you and through everyone you have ever known. And almost no one noticed. The machines noticed. Across the solar system, instrument after instrument suddenly screamed at once because something had just happened that was not supposed to be possible. The first to see it were 2 space telescopes built specifically to watch for cosmic explosions. NASA's Fermi Observatory and the Swift Observatory. These are seasoned machines. They catch gamma-ray bursts almost every day, faint flashes from the depths of distant stars, so they know exactly what an explosion looks like. They had never seen anything like this. The signal that hit them was so bright that it did not just register, it overwhelmed them. The detectors saturated, the way a camera washes out to pure white when you point it straight at the sun. At its peak, this single burst was pouring more than 6 million particles of light per second into the instruments. The previous record was around 500,000. For a few seconds, the machines humanity built to study the violent universe were effectively blinded, staring into something far brighter than they were ever designed to survive. And it was not only the gamma-ray telescopes. The blast was so strong that spacecraft never meant to detect such things felt it too. Voyager 1, out beyond the planets in interstellar space. Orbiters circling Mars. The pulse rang through the entire solar system at once. To understand what they had caught, you have to understand what a gamma-ray burst actually is. It is the single most powerful kind of explosion known to exist. When a star far larger than our Sun runs out of fuel, its core can no longer hold itself up, and it collapses in less than a second into a black hole. As that black hole is born, it does something almost unimaginable. It launches 2 jets of matter outward from its poles, narrow beams traveling at very nearly the speed of light that drill straight out through the dying star and into space. For the brief moment those jets are firing, a single one of them can release more energy than our Sun will radiate in its entire 10 billion year lifetime. Not over years, in seconds. It is the closest thing the cosmos has to pointing a weapon, and the only thing that decides whether you ever see it is whether one of those 2 narrow beams happens to be aimed at you. This one was aimed at us. Astronomers gave it a designation GRB 22-1009A, but very quickly it earned a nickname that has stuck ever since. They call it the boat, the brightest of all time. And that is not a casual exaggeration. It is a measured fact. This burst was somewhere between 50 and 70 times brighter than any gamma-ray burst ever recorded before it, across more than 50 years of watching the sky. We can even point to where it came from. The light arrived out of a small, faint constellation called Sagitta, the Arrow. The dying star that made it sat in a galaxy nearly 2 billion light-years away, which, by the standards of these explosions, is unusually, almost uncomfortably close. Combine that closeness with that brightness, and you get an event so rare that astronomers estimate a burst like this reaches the Earth only about once every 10,000 years. This was not simply a new entry in a record book. It was something that, on any human timescale, essentially never happens. And here is the part that is hard to shake. One of those two jets was pointed almost exactly at Earth. We did not catch this burst from the side, glancing off the edge of the beam. We were looking very nearly straight down the barrel of it. For 2 billion years, that column of radiation travelled across the dark, spreading and thinning as it went. And at the far end of that impossible journey, it found one small blue planet and washed right over it. The jet from one of these explosions is extraordinarily narrow, a tight cone in a sky that is unimaginably wide, so the odds that any given burst points at us are almost nothing. This one did. It is the cosmic equivalent of a rifle fired on the other side of the world, 2 billion years ago, with the shot arriving precisely where you happen to be standing. For most of these bursts, the story ends as a number on a graph. This one reached down and touched the planet itself. As the radiation swept past, it slammed into the upper layer of our atmosphere, the ionosphere, the electrically charged shell that sits high above our heads and that our long-distance radio signals bounce off of. And it disturbed it. Detectors in India and in Germany picked up the ionosphere reacting, the kind of sudden change we normally only see when a powerful flare erupts from our own sun, 93 million miles away. Except this did not come from our sun. It came from a dead star 2 billion light years out. The disturbance was strong enough to be measured in broad daylight, when the sunlight flooding our atmosphere should have drowned it out completely. A handful of photons at the end of a 2 billion year journey briefly rearranged the top of our sky. It is the first time a gamma-ray burst has ever been caught physically altering our atmosphere. Nothing on the ground was harmed, but the line between out there and down here got a great deal thinner that day. Then, in the hours and days that followed, the burst left behind something hauntingly beautiful. When the Swift telescope turned to study the fading afterglow, it saw the explosion ringed by a series of vast, perfect circles, expanding outward in its X-ray vision like ripples on a pond. The rings are an echo. As the flash of X-rays raced toward us, it passed through thin sheets of dust scattered across our own Milky Way, and each sheet caught a little of the light and bounced it back to us slightly late. Slightly off to the side, tracing a glowing circle around the point of the blast. Astronomers had only ever seen this happen around a handful of bursts in all of history. This was just the 7th, and where the previous record was a few faint rings, this burst lit up 20 of them, circle inside circle inside circle, 3 times more than anything seen before. It was as if the explosion had drawn its own portrait across the dust of our galaxy, in a language written only in X-rays. The numbers behind all of this barely make sense. A detector array high in the mountains of China caught individual particles of light from this burst, carrying energies of 18 trillion electron volts. In plain terms, these are photons far more powerful than anything we can create in our largest particle colliders, and there is a genuine argument among physicists about whether photons that energetic should even be able to cross 2 billion light years of space and reach us at all, instead of being swallowed somewhere along the way. There is even a disputed claim from a facility in Russia of a single particle carrying more than 250 trillion electron volts. If that one holds up, it presses right against the edge of known physics. This single burst delivered more high-energy light than astronomers had gathered from every other gamma-ray burst in history. Put together, it did more than break a record. It pushed past what the people who study these explosions thought was even reachable. But the strangest part of the boat is not how loud it was. It is what came after. When a giant star collapses and fires a burst like this, the rest of the star is supposed to detonate behind it, as a supernova. And a record-shattering burst should, by every expectation, be followed by a record-shattering supernova, an exceptionally bright one, glowing for weeks. So astronomers waited, and they aimed our finest eyes at the spot, including the James Webb Space Telescope, and what they found did not fit. The supernova was there faintly, but it was oddly ordinary, unremarkable, nowhere near as spectacular as a blast this violent should have produced. There was something else missing too. Explosions like this are thought to be one of the universe's great forges, the places where heavy elements like gold and platinum are hammered into being, and the models said this one should have scattered a fortune of them into space. When Webb went looking for the signature of all that newly made gold, it was not there. The most powerful explosion we have ever recorded did less, in some ways, than a far gentler one should have. And no one yet has a clean explanation for why. It is worth being honest about the danger, because this is usually where these stories get exaggerated. GRB 2020-1009A could not have hurt us. It was simply too far away. By the time its radiation had crossed 2 billion light years, it had spread so thin that it could nudge our ionosphere and nothing more. But the reason astronomers care so much, the reason there is a faint chill under all of this, comes down to distance. If a burst like this went off not 2 billion light years away, but a few thousand, inside our own galaxy, and aimed our way, it would be a very different morning. The radiation could strip away the ozone that shields us and let the sun's own ultraviolet light finish the job. This is not science fiction. One of the leading suspects for a mass extinction here on Earth, more than 400 million years ago, near the end of the Ordovician period, is exactly this, a nearby gamma-ray burst. We have no evidence that one is coming. The galaxy is enormous, these events are rare, and the odds in any human lifetime round down to nothing. But the boat was a reminder that the sky is not as quiet or as safe as it looks. Step back, and what happened in October of 2022 starts to look less like a disaster and more like a piece of almost absurd luck. For us to have caught this at all, several things had to line up at once. The burst had to be one of the brightest the universe ever makes. It had to go off unusually close to us. One of its 2 pencil-thin jets had to be aimed across 2 billion light years, almost perfectly at the Earth. And all of it had to happen inside the thin sliver of cosmic history in which human beings exist and have built telescopes capable of recording it. Move this explosion a little farther away, or tilt its jet by a hair, or let it arrive a few centuries earlier, and it slips past completely unseen, just one more flash in an empty sky. Instead, it arrived now, while we were watching, with every instrument pointed in the right direction. Astronomers may not see another like it for 10,000 years. We happen to be here for this one, and that is the thought worth carrying out into the night. Somewhere, nearly 2 billion years ago, a star many times the size of our sun reached the end of its life and collapsed into a black hole. And in its final instant, it threw a scream of light out across the universe in 2 directions. For 2 billion years that light travelled while galaxies turned, while our own sun and Earth slowly formed out of the dark, while life on this planet crawled out of the sea and learned to walk and finally learned to look up. And then, on an ordinary Sunday, it reached us. We did not feel it. We only saw the needle move. The universe is full of these. Every single day, somewhere in the sky, A star is dying in a flash that briefly outshines everything around it, and the light is racing outward, looking for someone to arrive at. Almost all of it never finds us. We see the few that do, and we are left to imagine all the ones we miss. The dark is not empty. It is loud. We are simply too far away most of the time to hear it. This has been Nightside, the half of the universe the light never reaches. If you would rather know what is out there than not, you know what to do. We will be watching.